So for section 5.8, we're going to talk about integrals involving inverse trig. And I'm kind of skipping over the derivative portion just because once you know what the integrals are and how to integrate it, then you would be able to take the derivative with no issue. And so the three that we're going to focus on, that the textbook focuses on, are these three. So we have that, we'll say that du over the square root of a squared plus u squared is equal to the arc sine of u divided by a plus c. So if you can get something written in this form, then you know that the integral of that is just arc sine of u over a. All right, then we have the du of just a squared plus u squared, so no square root. That is the arc tangent of u over a plus c. Or excuse me, sorry. It's 1 over a arc tangent. Let me rewrite that. So it's 1 over a arc tangent of u divided by a plus c. Yeah. And then the third one that we're going to talk about is secant. So we have the du over u times the square root of u squared minus a squared is equal to 1 over a of the arc secant of the absolute value of u over a plus c. So these are the three that we're just really going to focus on. And these are the three to know the derivatives of, in the reverse direction of the integration. All right, and so I have an example here that I want to go over on how we're going to go about these. So I'm going to say, let's integrate 30 over 1 plus 6x squared dx. Okay. Or excuse me, not 6x squared, 36x squared. Forgot this. Okay. All right, and so we're going to use a combination of u to u substitution along with what we know now as integrals of trig functions or inverse trig functions. And since I don't have any square roots or anything, I'm probably looking for something like arc tangent. Okay, so I'm going to say, let's factor out the 30 because it has no effect on the integral, and say this is 1 over 1 squared plus, I'm going to rewrite this 36x squared as 6x quantity squared dx. Okay. So over to the side, I'm just going to make a note to say, well, u is 6x. And so I'm using u to u substitution here, right? So then I have to say, well, du is then 6 dx. So then I'm going to bring that 6 over, so I'm going to divide by 6 and say, well, 1/6 du is equal to dx. So I'm going to then replace, right? So I should have 30 over 1 plus 1 squared plus u squared times 1/6 du. Right? All I did was replace my dx and my u value. All right. Well, the 1/6 can be brought out and multiplied by 30 to say, well, that's 5 over 1 squared plus u squared du. Okay. Now I have this in the form of my arc tangent. I've got du over a squared plus u squared. So now I just make the necessary substitutions into my inverse trig integral here. All right, and so that is 1 over a. Well, a is 1, so that doesn't change anything. So I have 5. All right, I just have 5 times 1 over a is 1, so nothing. Then the inverse tangent of u over 1 plus c. Well, my u value, of course, is 6x, as I decided earlier. So I have 5 times the inverse tangent of 6x plus c. Okay, and so that is how we can use UDU substitution along with integration of inverse trig to find an integral when we have something in this form. Okay. All right, the second example that I'm going to show you is going to take a little bit more thought and how we're going to go about it. But we're going to say that let's take the integral of x minus 6 over x plus 3 quantity squared plus 36 dx. Okay. All right, so I know that I'm using UDU substitution, and I know that usually I let my u be the denominator, right? That's what we've been discussing with like natural logs. I let u be the denominator, which is what I'm going to do here. But when I take the derivative of my u, I need to make sure that it replaces something in the numerator. Okay, so I can rewrite this numerator so that when I take the derivative, right? So let's go ahead and look. Let's go ahead and do the u part. So let's say I have x plus 3 quantity squared plus 36. Okay? When I take the derivative of that, I'm going to get 2 times the quantity of x plus 3. 36 is 0, so that's nothing, right? Dx. Okay, so then I'm going to bring the 2 over, so I have 1/2 du is equal to x plus 3 dx. Right? So I need to make sure that I have an x plus 3 that I can replace in this numerator. So I'm going to rewrite this integral to say this is x plus 3 over the denominator. All right. To make that still be true, I'm going to say minus 9 over the denominator. Right? X plus 3 minus 9 would still be x minus 6, so I haven't changed the value in any capacity. All right. But I just rewrote it to where I have something with a du that I can replace. And now I can use some inverse trig for the second one. Okay, so I've already done the UDU substitution for the first part, right, by finding my u, getting du. So this first component here is 1/2 1 over u du. Okay. For the time being, I'm just going to let this other one tag along and take care of it in just a moment. I want to take care of this first component first. Okay. Well, we know that when we take the derivative or the integral of 1 over u, we just get the natural log. And if you feel like you can do this simultaneously, that's perfectly fine. All right. So I know that the integral of 1 over u is the natural log of u, the absolute value of u, plus c. Okay. Well, I'll go ahead and replace that u and say the natural log, so u is this x plus 3 squared plus 36, and I can drop my absolute value because I know x plus 3 squared will always be positive. Okay. All right. Now I'm going to focus on my integration of my -9 over x plus 3 squared plus 36. Okay. Well, the first thing I notice, of course, I can pull this 9 out, right? And I can say, well, this is 1 over x plus 3 squared plus 6 squared. Notice I rewrote the 36 as 6. All right, I don't have to do any UDU substitutions here because it's already in the form that all I have to do is write down my, looks like inverse tangent integral again. And so I'm going to say that's minus 9 over a here is 6. 6 is my constant. The inverse tangent of u, which would be x plus 3, the x component, over a, which is 6. And of course that's all plus c. So I'm going to clean that up a bit and just say that is 1/2 the natural log of x plus 3 squared plus 36. And if you wanted to FOIL that out and do that, that's perfectly fine. 9/6, that simplifies to 3/2. The inverse tangent of -1 over x plus 3 divided by 6, all plus c. All right, and so there would be your final answer. All right, using these two examples, that should be enough to get you through all the homework problems. If you do have any questions, please feel free to email me, and have a great rest of your day.